In this video, we're showing the first op toward making the backplate for the barrel fluting machine. Due to the size of the stock, we could only run this on my 3-axis CNC mill with an Allen Bradley 8400 MP controller. The problem with the MP400 8400 controller is that the size of the memory storage on it is not as great as, say, the Haas or the Sharps that we have. And due to the Z-axis on the table, we only had 5 inches of travel in CNC. We could lower the table up and down to compensate for this. So then we ran each tool as a separate program. This plate has been designed to allow us to move it for multiple setups and still maintain alignment and clamping ability. This was accomplished by drilling and reaming 3 5/8-inch holes for alignment and 6 holes for 1/2-13 bolts for clamping down the plate. The initial setup was using the clamps with 1, 2, 3 blocks holding the plate up off the table so we didn't take a chance of damaging the table. So as we're doing this, because of the size of the machine and the horsepower rating on the machine, the first set of programs did the center drills for all the holes that we're going to do, and then we went through, as you can see in the video right now, we drilled pilot holes on each of the individual holes. This was a 3/8 pilot hole drilled through the entire plate. Then we went back, ran a program to do 19/32, and then an additional program to do a 35/64 for the final drill sizes. We did our counterbore for the 1/2-13 cap screws that we're running using a reground 11/36 carbide end mill. And you'll see this part coming up shortly in the video. It just did a real nice job. Instead of trying to use a standard counterbore, we just went in, pocketed it, and brought it up. We did experience chatter on this video, on this part, and you'll see that in the video coming up as well. When we clamped this, there was only certain places we could put clamps down, mainly because it's wider than what the table allowed, it's longer than what the table allowed. So when we got to the last hole, we experienced a fair amount of chatter drilling the hole. What we did to compensate for this, we stopped the machine, and then we used a C-clamp to clamp that to the table. You can hear the chatter right now. The clamp was only used during the holes that we were drilling at this part of the table. And after we got done, we removed the clamps for every time the table was going to move. We just stopped the machine, removed the clamps, let it go to the next hole, and if we needed to clamp it again, we did that. This is the 11/32 end mill going along. It's carbide, so to show you a little better of what's going on here, we turned off the coolant because it wasn't really needed, but we had huge chip buildup in the hole anyway. So we used a great air pressure to constantly blow out the chips, even though we had coolant here, and later when we removed the coolant, we still had to use the air pressure to remove the chips. So you can hear it operate now. This is running about 2,500 RPM. It's the max for this little machine. We had a fairly slow feed rate on this, as you can see in the video. Now with these holes completed and drilled, reaming will be the next step. And once that's done, we'll clean off the table. We'll reset our blocks using aluminum blocks instead of steel 1, 2, 3 blocks because of the number of holes we're going to drill. And then we'll clamp this directly to the table with the 12/13 bolts and allow us to drill all the holes, alignment holes for the bottom half, plus do the outside edging to true it up. And when we're done with that, we'll move the whole plate down and redo it again after we dial it back in. I hope you enjoyed the video, and have a nice day.